I will start my session firstly thanking Mr. Alex and all his team members from ToxMaster Class India. And indeed, it's genuinely appreciable to everybody, including the all teachers and all the attendees. And because it's a great initiative to start preparing for the DABT examination, and all the almost more than half classes have been completed of the total lectures, which was based on the cassette and all chapters. So it's like we have completed more than half, and the exam will be happening in the October. So there's not too much time to prepare for the examination. But this lecture that I have prepared, it's not just for the DABT. It's also for all the people who are interested in toxicology or who are passionate about doing something in the field of toxicology in their future. And it's genuinely a great pleasure for me to be part of this initiative. It's just like it's like a uh, point of interaction where I can be interacting with a lot of people. And in the last, I will be sharing my contact details if for any reasons, not just for the reproductive toxicity systems and anything like genotoxic impurities, but anything that can be of help. I will be very much thankful if anybody contacts me and get some insight in that part. So, without wasting much time, I will initiate this lecture, and it will be roughly around 1.5 hours for the slide discussion that will be from my end. And after that, we will be having a question and answers where we will be discussing any question that you have, and then we can conclude it. So, it will be roughly around 2 hours. So, I am guessing that you are ready with your popcorns and anything that you wish to have for this long session, and we hope we enjoy this session. So let me start this session. So the topic for this will be the toxic responses of the reproductive system, and mostly the reproductive system is the study that are generally conducted. It's always along with the developmental part of the fetus and embryo. So, but here I will be solely covering the reproductive part. Meanwhile, there will be situations where I will be discussing for the developmental part also, but the core session will be for the reproductive system. So, I guess if you are having any questions, you can have a question, write down the questions, and in the last we can discuss that part. So, this will be what all we will be discussing throughout the lecture. So, this will be the global landscape and the past incidences. The second will be the reproductive system for both male and female. Then again, we will be going to the categories of the reprotoxicants, and then we will be covering the regulatory part, the regulatory requirements from the agency, and the study designs that they expect. And then we will be covering the endpoints for the reproductive toxicity study, and then statistical interpretation of all the findings that have been gathered from the studies, and what is the future of the reproductive toxicology, because these days um, a lot is happening in the AI and
Where are you today?
AI and organoids. So that we will be covering in brief. There might be questions from the ABT, the ABT team. I will be briefly covering that part. And in the last, we will be having summary, and then we will be discussing the questions. So the global landscape and the past incidences. So firstly, why do we actually require any reproductive toxicity study? Because with the advances in our lifestyles and the things that hampers our life, it's actually the global reproductive health actually is deteriorating, and one out of 6% are like the couples or male or female, they are experiencing infertility related issues. And global infertility statistics are considering both male and female, roughly around 20 to 30% couples are affected, and if only considering the male, it is roughly around 20 to 30%. In all, it means roughly around 20 to 30%, uh, like all over the world, they are suffering through the infertility and any types of reproductive
Hey,
toxicity.
zombie.
So this assisted reproductive toxicology technology, actually it's shortly called as ART, and it includes all the methods that are assisting the couples and the males or females that they can have a child, right from the fertility related issues to the test tube technology. And in Europe, 7% of the total births, and even it's similar in the US also. So they are having the 7 to 8%, 7 to 15%, they are facing similar challenges with reproductive challenges. So, what are the actually what I will firstly I will discuss like what are the main causes and factors that leads to infertility. So, it's the ease and the stress, the work like many points that cover from like stress is mostly from the work and offices, so that ultimately affect the infertility part, and also the late if we are very much uh, addicted to the cell phones and the LCDs, and it actually affect our endocrine system and also the pineal gland, and that ultimately hampers our hormonal balances and it causes infertility. So that is a major factor that also leads to infertility. Health problems, other health problems may lead to reproductive toxicity and challenges. So STD, then overweight and underweight, we will be discussing that part. Overweight is definitely having an proven records, even nice and rare studies that have proven that overweight is causing fertility-related issues, radiation, chemotherapy, heavy alcohol use, smoking, drugs, and environmental toxicants. They all lead to the factors. These all are the factors that are contributing to the infertility. And what are the main causes that leads to? There are multiple causes, but in the last that I have mentioned that it's unknown. So mostly the 65 to 70% of the reasons that actually lead to reproductive toxicity in general are unknown. So, why at all the reproductive studies are conducted and they matter? So, throughout the slides, I have divided all the parts into the drugs and the chemicals. So, drugs, because their intent is different part, and chemicals, their intent is another part. Because chemical, they are not supposed to be interacting with the human, but the drugs are supposed to be interacting with human body. So, both are considered totally different, and the agencies are different, and they consider different results from the study. So for the drugs, uh, it is ensured that the therapies that are given to reproductive and like if a drug is expected to be exposed to the individuals who are reproductively active and women like if they are of capability of having any childbearing capacity. So if the drug is having a potential to affect them, then these types of studies are required. And also for before any approval of any new drug, it is required. And if we are going to phase 2 or phase 3, so before going to an even at the trial basis and even after the approval of the drug, it is expected that the prototype studies are submitted. And S5, I said S5 and the recent guidance is revision third, so it covers most of the parts for that. And especially for the hormonal agents, because these days a lot of hormones are also marketed by the pharma industry. They are to be tested for the reproductive toxicity vaccines and biologics. So actually earlier S5R2 didn't cover the vaccine and biologics part, but recently it was covered in the revision third part. So that is like an important thing that needs to be checked for the reproductive toxicity. And for the chemicals, chemicals include like agrochemicals, industrial chemicals, and consumer cosmetics, and that part are considered in the chemicals, and they include the plastics and pesticides and cosmetics. So they all interact with us and they affect our hormonal balances in gamete and even affect the fetal health. So that is the thing that leads to the requirement of reproductive toxicity studies being conducted on this part. And also for the occupational and environmental exposure, all the chemicals that have the potential to have an exposure to the human system that requires an reproductive toxicity. So, firstly, I will cover all the past incidences that had led to the agencies to be considering all the reproductive toxicity studies seriously, and they require a stringent GLP study to be conducted before the chemical or the drug is marketed. So thalidomide, it was in the 1950s and 60s. It's one of the most famous compound that is given an example in any toxic studies, like in toxic interactions. So that was an sedative and antiemetic drug that was used by the pregnant females, and it led to the focomelia and that developmental toxicity had in cases of more than 10,000 worldwide, and it disrupted the angiogenesis part, and the limb buds were not developing properly. And ultimately, that led to it awakened the regulatory agencies, and then that it was decided that we should be very much careful. And thalidomide, like rodent species, like rat was not predicting the proper toxicity. So that was an incident where the requirement of two species was mandated for at least for the embryo development of toxicity studies. So generally, segment two, it is considered from the ICIS perspective, it's segment two. And the second cases was the diacetylglycerol. So DES, and it was to prevent miscarriage in the pregnancy. So no, it was not a drug. It was a chemical which led to the miscarriage of the pregnancy, and the outcome was the reproductive anomalies and vaginal cancer in the daughter. So, if a woman who is carrying a child, which is the child is female, so a female inside a female. So, if that the mother is exposed to the cholesterol, so even the child which is not still born, and even its ovary is affected. So, the generation that is still inside the womb, it's also affecting. So that was like very much awakening for all the regulatory agencies which are like following WHO and OECD guidelines. So, and this methyl mercury in his lecture by Alex, he also briefly covered this methyl mercury part, and it's not only cover like neurodevelopmental challenges were there, but also some because of mercury, there was some developmental neurotoxicity also. And CCBs, these are chemicals which are generally inside the industrial coolants and plastics, and they are bioaccumulative in nature, and they reduce the fertility, and they delay the puberty and enter the sexual level. So this was like all these incidences actually led to the requirement of reproduction. And pallets, these are also very much news in these days, and particularly for the plastics and the personal care products, they are very much in very higher amount they are present in those products, and they definitely affect the male reproductive system, and the malformation includes the testicular degeneration part. And it has been observed that the embryogenetic distance in the female increases because of the pellets. So anti-androgenic effect in vitro, the mechanism by which it acts is anti-androgenic effect in vitro. And bisphenol A, like BPA, is like very much famous these days, and food packaging and many materials cover that part. Even in Europe, the bottle, the feeding bottles given to the babies, they used to contain the bisphenol A. Now it is highly regulated there, but it leads to ovarian dysfunction and many puberty-related challenges, and poor sperm quality have been observed both in the animals and the humans. And PFAS, like these are called forever chemicals, and these are very much news in these days. Even there's a video on YouTube, if you can search for that part. It covers it is having more than I guess more than 2 million views, and it was covering all the challenges that is because of the PFAS, because they are called the forever chemicals, and it is because of the F and C and F bonding, and it is between the carbon and fluorine, and it is so much strong that even the nature fails to break that bond, and then it is virtually present in the environment for a very long time, and it ultimately causes a very challenging situation, not just in the fertility, but many other toxicities are because of the PFAS, and the birth rate is lower side, and fertility is definitely a very challenging situation which is caused by the PFAS, and even the hormonal balances are compromised, and immune effect. PFAS are very it's a big no-no for any agency, because it is like if we count down all the negative points of the PFAS, it will be a book. So, if you would like to have any understanding of PFAS, and if you're not aware, there's a video on the YouTube, you can watch that part. And pesticides, obviously, they are in nature manufactured to destroy some organisms, fungicides, and herbicides. So they definitely have a deep effect on the fertility of males, and it is called delayed puberty. And flame retardants like PDBs and organophosphates, and they are present in the furnitures and electronics. They also causes severe challenge in the hormonal part. That the PBDs, they mimic the thyroid hormones and disrupt the thyroid hormone signaling. And OPFRs means like organophosphate flame retardants. They interfere with the HPG axis, and we will be discussing what HPG axis is and how any chemical that is having an influence on the HPG axis, how it can severely impact the whole overall well-being and reproductive challenges can be caused because of it. And it is very much banned in many of the regions, and but still they are present in a lot in the environment. So this we will be starting with the reproductive system, and firstly, before going to the male and female, briefly this is the cycle of the uh, reproductive part, and starting from the gamete production and release from an adult. So these lead to from male and female, the gamete productions are generated and ova is released from ovary, and secondary oocyte is released from the ovary and from the male system. So they fertilize, they fuse and they fertilize, and the zygote is formed, and the implantation happens in the embryogenesis. After the implantation, embryogenesis happens, and the fetal development happens after embryogenesis. And I have mentioned um, mostly the system is going towards the female system until and unless the Y chromosome kicks in. If there's a Y chromosome present there in the zygote, and the SRY gene in the Y chromosome, it will cause the testicular organogenesis, and the Mullerian duct won't be forming there, which might have led to the formation of female embryo, and the male Wolffian duct will be prepared. So there it will be decided whether it will be a male child or female child, and then after the development, whole organism is complete, and then the parturition happens, delivery happens, and the embryo comes out and becomes the fetus, and then the lactation it grows and it achieves its lactation it passes through the lactation part, and postnatal development happens, and then it again grows and development happens, and again it attains the sexual maturity and the second generation form. So ultimately all the chemicals that are affecting it is either affecting any of these um, stages, and it is leading to the reproductive. So gametogenesis, firstly covering that part. So it is the formation production of the gametes, and it begins with the developmental of primordial germ cells in the genetic phase. And the meiosis is the main part that happens, and where the haploid gametes are generated, and the male meiosis begins at the puberty. But for the female meiosis, it begins at the fetal development, and but it arrests at the meiosis one and then meiosis two, and until fertilization, the meiosis part is not completed, and oocyte is available to a female complete at the birth. So for human, it's like roughly 4 million oocytes are generated at the initial stage when it's in the utero, and by the time the female reaches 30 years of age, roughly around 25,000 are only available. So females are having a limited number of secondary oocytes, and from males, it's not the case. So based on the both criteria, both males and females are having different critical periods where any toxic and impact, if it's there, it will affecting the whole part. So this male and female part that we will be covering later on. So, just for the relative comparison between the rat and human, because most of the studies, not most, all the studies are conducted in the rat, because we can't expose to the human. So just for comparison, there's a short gestation period in rats, and that makes it a very much reliable species from the terms of like gestation period. Obviously, it could be pharmacologically sensitive and specific species to be chosen for large molecules. That might not be the relevant species, but mostly that is the main generally considered for segment 1, 2, and 3, or for the chemicals or chemical generation, or most of the studies it considers that, except for the additional requirement of rabbit in the amphitheater, general segment 2 study. So short gestation is there in the rat as compared to human. Placental lacks aromatase, but here in human it is plus. And the estrus cycle is 4 to 5 days. Uh, and in human, it's the menstrual cycle is 28 days. And sexual behavior is influenced by the estrogen and progesterone in the rat, and sexual behavior is less dependent in humans, and it is mostly decided by the psychological factors. In evolution, and that happens spontaneously. Multiple ova are released per cycle, but for the human, one egg is released in 1 month, and from both the ovaries, one by one, on each month they are released by both the ovaries. And litter bearing capacity in rat is very much higher, and human is generally one or rarely twice higher, not more than two generally. And spermatogenesis starts in the roughly around fourth day of postnatal in rats, and in human it starts at roughly around 10 to 14 years. Puberty achieved at 32 years in rats, and puberty for humans is 12 to 14 years. Fertility declines by 6 and 8 months. So mostly all the studies that are to be conducted, it is conducted before they achieve the 6 or 8 months of treatment. So this is basic comparison between rat, mouse, and other species and other animals which can be correlated with the human. And mostly the parts that mentioned here we have already covered in the other slide. And from here we will be starting like for the hormonal part. So HPG axis and HPA axis, it is for the from the perspective of hormonal challenges, like even the endocrine disrupting chemicals. So this is the main thing that it should be understood if we have to conduct any study that might be challenging the hormonal balance. So HPG means hypothalamus pituitary and gonad axis, and here briefly saying all the system, this is a complex system actually, but briefly mentioning like the CNS interacts with the hypothalamus, and from hypothalamus the NRH is released, and it interacts with the pituitary, and it guides the pituitary to release the LH and FSH, and LH and FSH then interact with the gonad for male and female, and accordingly, the sperm production and overproduction are regulated, and ultimately the whole system is having a negative and positive feedback loop, and it balances itself. And in the HPA axis, the hypothalamus pituitary are same, and for the adrenal cortex, it leads to the development of other um, sexual responses. So, just to give an idea, like for LH and FSH, LH in male, they interact with the Leydig cells, and they then ultimately leads to the formation and synthesis of testosterone. And for male, the FSH interact with the Sertoli cells that are outside, that are inside the seminiferous tubule, and which leads to the spermatogenesis. And for the female, LH interacts with the Zika cells, and then it leads to the androgen synthesis, and the FSH interact with the granulosa, and leads to the estrogen via aromatase. In between aromatase is formed. So this is like the write-up for the everything that we have discussed for the HPA and ovarian function. And one thing I will want you to understand, like once the HPG axis is activated, so the organ attains its sexual maturity. So HPG, like its functionality proves that the animal is now sexually mature, and when this HPG is compromised, and by like for females at menopause, this is also like when it's been impacted, then only the menopause and other infertility related other stages in anything that leads to sterility or anything. So HPG is challenging. So this is the main reproductive system, and this is saying that the sperms are produced in the seminal vesicles, and they move towards um, uh, during development they move toward the retrotestis and then epididymis, and at the time of mating through the seminal vesicle and prostate gland they are ejaculated, and they are ready to go inside female, and we are doing sex, and then the fertilization happens. So this is endocrine control the male production. So PNF interact with the hypothalamus and GnRH interact with the anterior pituitary part. And like I had earlier said that HLH interact with the Leydig cells and that leads to testosterone. FSH interact with the substrate and inhibin B is produced and by negative and positive feedback, the whole system is balanced. So in the rat, um, the spermatogonia develops into the primary spermatocyte. They later then through meiotic divisions divide into haploid parts and round spermatids are uh, prepared, and then elongation of the spermatid happens in the spermatozoa happens. So it's for the rat. So hook shaped sperm is ultimately generated, and the caput part of the epididymis they are stored and until the ejaculation. So for the male reproductive evolution part, like for the male fertility studies and wherever the male reproductive system is to be evaluated, these are all the parameters. Mostly the top four, like 4 or 5 in the initial part of this list, they are basically calculated like for the sperm count, the total number of sperms per ml of the female, it is counted. So the concentration is counted if there is a less number of sperms per volume, and the sperm motility is also checked because if sperms are not very much motile and if they are losing their motility, and it's because of some morphological part, like there are teratozoospermia where like the sperm is not very well developed. So the sperm is actually divided into 3 parts. So the head part and the neck piece and mid piece and then the tail part. So there might be challenges where the sperms are not being formed. They might be having 2 tails or 2 heads or bent neck, or there might be many challenges to the formation of the sperm. So that can be in the checked in the sperm morphological part. And sperm viability, like sperms might be available when we are sampling the sperm from the male fertility study or another study, but they are not viable, they are dead. So it ultimately leads to the conclusion of infertility. And there are multiple other types of evaluating parameters like exogen integrity and sperm membrane and sperm kinetics, like for CASA, the computer assisted sperm analysis system, and the motility and the speed and the movement, like they should be not randomly moving, they should be moving in one direction, and all those parts are done by the CASA system. Manually also it's been done at many facilities, and the main purpose of those studies and those evaluation are to just check like the sperms are in very good condition, very healthy condition, their count is good, their concentration is good, and they are very much capable of fertilizing the secondary cells. So the challenges that can be happening at the whole system of hormonal balance. So, like dopamine antagonist may interact with the CNS, and that can lead to not interaction, like the hormones reaching pituitary glands, and estrogens might impact the pituitary glands and testicular vasculature. Like you might be aware, the testes are outside the body just to maintain the lower temperature. So a vascularized system is well maintained there, and if the cadmium is there, so it may impact that part, and it may lead to the disruption of that vasculature part. So it will be ultimately leading to the temperature. It will hamper the temperature balance that is required for the proper spermatogenesis. So cadmium can also be part of disrupting, but this whole system of hormonal parts, actually it's all depending upon each and other system. So that is the reason, like the organoids and organ on chip, they are not so much efficient because there might be scenario like here in the lever on the right side, you can see that the carbon tetrachloride is also mentioned. So, if the carbon tetrachloride is human is exposed or the system is exposed to carbon tetrachloride, and it is hampering a lot, and it is causing liver toxicity, and the steroid hormones are not metabolized as they should have been. So, it would definitely lead to challenges in the spermatogenesis part, and ultimately it will be a reproductive toxicity. So whole system is dependent on each other. So any toxic can which might be affecting one system, and that is indirectly or directly connected with other systems. So ultimately, it will be leading to that. So even at the lower side, you can see at the fertilization part, the antibodies may in fact some exposures can lead to, and even because of genetic challenges and exposure to various toxicants, they lead to the and sperm antigen uh, generation in antibody generation in the body, and that can also lead to the challenges which will be considered as a reprotoxicity. And cyclophosphamide also, these are well-known cytotoxic compounds which are actually considered as in positive control in many cytotoxicity studies, and that interact with the DNA and they um, lead to the DNA cross binding, and ultimately the cytotoxicity is there. So ultimately, if it is a system is human system or a test system is exposed to cyclophosphamide, the very much possibility that it will be infecting the germ cells and the form, so it will be leading to ultimately it will be leading to that. So just these the toxicants that may be affecting the male gametogenesis are the cytotoxic. It may lead to azoospermia and oligospermia, like no sperms are there or very less sperms are there. Even 50% of total count may lead to fertility part. It's not generally considered as sterile, but a very less number of sperms are definitely called as oligospermia, and no sperms at all is oligospermia. And the endocrine disruptors, like I shared earlier, or the phthalates, they lead to disease in the testosterone. And this biomarker, like it's been found through the CASA system or manually counting that the sperm counts are and the motility is observed there. So if it's been happening for a longer time, that it many times it's been identified that testicular atrophy is there. So just it's a brief pattern here. So there's here the forms are demanding that the pellets should be stopped, and here DPC being saying that you should be caring for your. So that was for the male part. This is the female. So female, mostly you will be aware that as an example, there will be an ovary and ovary duct is there. This is for the rat, and uterine horn is there, and female is there, and this is there. So for the production for this secondary oocyte and uh, um, female reproductive part. So the production actually happens when the fetus is like the female is in her like in her mother's womb. So from there itself the germ cells start dividing, and the meiosis part is there, and for a long time it's been arrested in the meiosis initial stages, and after the injection of FSH and LH from the pituitary, the primary follicle uh, advances into the secondary follicle, and then later on the Gracile follicle is generated, and later at the later stage this is ovulatory follicle generated, and at the time of fertilization actually the meiosis two completes, and then the chromosome goes. Endocrine control of the female reproductive system, it is somewhat similar to the male, and gonadotropin releasing hormones are there that impact with the anterior pituitary, and LH, and prolactin hormones are generated, and estradiol and progesterone are generated, and they interact with the anterior pituitary and hypothalamus with positive and negative feedback, and ultimately they take care of the vagina, cervix, uterus, and oviduct. So just for comparison, it's the human and rat uh, comparative endocrinology. So above human system is there, and below the rat. And for humans, 28 generally 28 days of menstrual cycle is considered as established way to compare anything. And for rat, it's roughly around 4 to 5 days of estrous cycle that we start with proestrus and PEND usually. And here we can see like the LH surge is there just before the ovulation for both the male and human and rat, and just before the LH there is FSH surge that precedes the LH surge. And because of these similarities, a brief idea can be calculated from a compound, a chemical, like it will it be having any impact on the menstrual cycle in the female, but in females? But obviously there are many changes. Like extra cycle is not that much similar to human extra cycle, but just for understanding and if there is like major impact that may be happening in the rat, so it will be translatable to the human. So just for understanding and comparison, it's very much it's been very much useful for conducting such exercises. So here, like we can see that for the ovulation part, this is for above is the for humans and below is for rice, is for rat, and the ovulation just happens in the prostate part, and just like there might be question which may include this part between comparison between human and rat. So like this, the whole period takes roughly around 4 to 5 days, and just to having some understanding, the half the period of the diastress is diastress, and half the period of coestrus is metastress. It's not fixed, but just to have an understanding, it can be calculated. So for most of the time, it's diastress. So this cycle will be helpful on to understand that. But right on the right, it's for rat, and the green part that is of the leukocyte. So the largest period in the whole cycle is the diester, and it is can be identified. This the staging of the cycle can be done through vaginal smear. Vaginal smear is taken from the female, and it can the cells are identified on the slide because the as per the cycle the female releases the cells and it can be well uh, observed in the microscope. So what is done in the vaginal smear is like identifying the cells that have been observed in the vaginal smear. So for the digestive part, the most of the cell will be leukocytes, and then from digestive it goes to the prostrate part, and prostrate is mostly covered by the nucleated epithelial cells, and then estrus part, which is the main part. So the estrus part, the conified epithelial cells are there, and in the metastrus part, it is the mixture of the conified cells and the leukocytes, and in the diastrus again, it will be going to the leukocytes. So here in the table, it can be very much understood like in the co-estrus, there's a surge in the estrogen, and it is the place where at the end of co-estrus the ovulation happens, and in the estrus part, the female is receptive for mating, and in the other side also we have seen that in the initial part, the electron happens, and the metastress part again, like it's actually the stage between estrus and diastress. That's why it's called metastress. It's not very much a longer duration, but the diastress phase when it starts going into the estrus phase when it starts to going into diastress part. So there's a mixture of both the cells, so that is called the metastress. So it happens. It has to identify with the change. So the overall purpose of this identifying this stages is to check whether if the toxicant is having any impact on the stress cycle or not. If the cell like this is the ideal cycle, and if for any reason the female is in the distress stage itself and it's not going to the post-stress stage, so it can be concluded and it can be understood like there might be some situation. And obviously, only one stage, like only one cycle is not checked. Mostly, I think 3, 4 cycles are checked just to ensure like whether the female was having good cyclic history or not, even before the toxicants are exposed. So in the coming part where we will be discussing for the study, we will be discuss how this cycle is evaluated and how it can let us understand the effect of toxicants. So these are the toxicant, like these are the list of toxicant that can have impact on the button. As I said, this type of is very much like cytotoxic in nature and leads to suicide process. Endocrine and heavy metals, they all impact the human hemoglobin. Fertilization is the fusion of both male and female gametes, and then a genome from one generation is passed to the next generation. It begins with the development of new organism. Suicide is is formed of two layers. The outer layer is stimulus like, and the inner layer is especially matrix, which is actually the called zone of pellucida. And to reach the outside, the sperm must penetrate both the layers. And the release of sperm, the enzymes are there in the exosomes, and that helps it to visit the ovum, and then the zygote is formed. And for the implantation and pregnancy, once the zygote is formed after the fusion of the both the gametes, blastocyst is there, and it implants to the endometrium, and it's covered in four stages. A position where it places itself, then penetration happens, then deciduation happens, and toxoplastic invasion is there in the stromal vasculature for the completion of implantation. The placenta mediates the exchange between the mother and fetus. For human and monkey, the placenta is hemopurial, and for rabbit and rat, it is different and hematoendothelial. So, and the following part is like pasteurization where the delivery happens. So, just to cover like in brief, the secondary oocyte is released from the ovary, and then it goes um, to the help of membrane. It goes inside ovus, and then fertilization happens there, and zygote is formed. And earlier in the earlier stage, the morula stage is generated, and then blastocyst is there, and it's roughly around 6 or 7 days the implantation process. So for the lactation part, the prolactin is a hormone that induces the lactation after the delivery, after the postulation is happened, and oxytocin, serotonin, and determines modulate lactation release. And endocrine disruptions uh, these days is a major focus in the lactation, and it's been found after postulation that the AGD, like androgen system, uh, and boys is reduced ideally as compared to females, even that and the energetic distance between males and females are different. So for females it's less, and for boys it's more. So if there's a reduction in the AGD, it's of concern, and also it leads to the endocrine chemicals. It leads to the a low testosterone production in males. And there are like two basic tests that are conducted for the like checking for endocrine disruption. The Hertzberger assay is there for checking for any androgenic activity, and uterotropic assay for checking estrogen, progesterone, and progesterone. The chemical and the product types that are regulated by the different agencies are listed here. So for human pharmaceuticals, it's the this S5R3 actually is roughly incorrectly mentioned as 6. S5R3 is the guidance which include the FED, EFD, PPND, which are for the human pharmaceuticals. And for the veterinary drugs are there like CVMP and CVM, which the Center for Veterinary Medicines are there, which includes which follows ICH and both OECD guidance. For agrochemicals, there are different agencies which check for the productive toxicity studies for agrochemicals, like for USCCP and for EU, EFSA, and OECD guidance are followed. We will be discussing the details of the studies later on. And for the industry chemicals, REACH is there in EU and PSA in US. And for food additives, cosmetics, and environmental chemicals, and also for the medical devices. All these are the categories actually which require the reproductive toxicity studies to be conducted to ensure the safety to the human. So, like uh, these are the domains which, like was present earlier in the table. So, briefly, we will be covering it here in the domains. Like you can see, there are multiple domains for human pharmaceuticals, and why it is required, because the drug needs to be ensured for the reproductive potential, like if there's any potential of having any reproductive toxicity because of the human drug. And if specifically if the exposure may happen to the woman of childbearing capacity and to the pregnant female, and the studies that are conducted, and typically they under ICH-5R3 they are considered as uh, segment 1, 2, and 3, and examples are thalidomide, isotretinoin. For veterinary drugs, mostly there are many hormonal growth promoters they are given, and it requires the multi-generation studies to be conducted there. And for agrochemicals, similarly, the situation is there, and it may require up to 2 generation reproductive toxicity studies, and OECD 443 therefore extended 1 generation EUG RTS studies. And for industrial chemicals, again, REACH EU is there, and it is screened for 2 generation studies and OECD 421, 422 studies, and lead, pellets, and BP are the examples of the industrial chemicals which have been found to be reproductive toxicity, and the studies are to be conducted for approval of those chemicals to be present. And obviously the as the parasite says, like it's the dose that decides the toxicity. So ultimately the agencies are checking for the levels that are proven by the studies, like up to what level the studies conclude like if it's safe for the human exposure and consumption. And for the personal and cosmetic uh, products, obviously you is not in the favor of that much for the animal studies, but there are very much development in the in vitro, which includes NAMs, and then because of CR, reduce refine and replace. The studies are like in the direction of moving away from the animal. For the environmental and environmental chemicals and pollutants, like OECD 210 is there for future life development studies, and estrogenic capacity and endocrine disruptors are checked for that part. And medical devices and for biomedicals, obviously there's the requirement of weight of evidence studies to be conducted, and in vivo the prototype studies are required there for food additives in the. So we will be discussing like what is the regulatory requirements and what types of study designs are there available for different chemicals or the drugs. So basically, like as I have earlier told earlier, like for drugs and chemicals, the intent is different of their production. So the study is required for them is somewhat different. So for drugs, like it is produced to be for the purpose of human consumption, and a major dose uh, is defined for a defined period, exposure for a defined period. And for chemicals, like it's uncontrolled and it's unintended exposure is to the human. So ultimately, the studies are conducted in such a design, like such a fashion, like the exposure happens for a longer time in for the chemicals and for the drugs because it's been intentionally consumed, so the exposure period is different for them. So, considering from the perspective of drugs first, so ICSS-5 have divided like the whole part of sensitive periods into 6 parts, and it can be divided into A, B, C, D, E, F, and E, N, F. So, for the first part, it's the pre-mating to conception, that is in crucial period where something can happen, and it is identified whether if there is toxicity happening before to the conception part, and then for from conception to implantation, and many of the part is covering here, like it's for the developmental toxicity also. So, but I will be focusing on the reproductive toxicity, but wherever it will be overlapping, I will be same part also. So, for the seed, for from the implantation to closure of hard pellet, actually that period of organogenesis where the organisms are generated, and the closure of hard pellet concludes the organogenesis. And again, in the D part, like it's for the from the closure of hard pellet to end of the pregnancy, and then from birth to weaning, and ultimately weaning to the fertility. So this is the basic design, which includes like segment 1, 2, and 3. You can see like for the first part, the green one, the dosing is concluded, and the purpose of the segment 1 study is to check for the fertility part, mainly fertility part, not for the organogenesis and other parts. And for the segment 2, it's particularly for the organogenesis part, it covers the dosing. The exposure is happening there in the from the period of implantation to hard pellet closure. And for the segment C, it's a longer period of exposure where the exposure is happening from the start of organogenesis to the birth and weaning process. So, but the segment 2 is basically designed to ensure and check for the organogenesis if there is something the toxicant is causing some teratogenic impact or the development of the fetus, is impacted. So the purpose of segment two is particularly for the from the perspective of fetus development. But segment one and three it includes fertility part and in the coming slides we'll be checking how actually that is been checked. So for the segment one, two, and three, you can see in the slide this table. The segment one is actually the fertility and early embryonic development part, and the study is designed for the rodents. On obviously, it's the basic design, but based on the if it's a biologics or large molecule, the like species is selected based on the uh, uh, similarity with the humans. And for the small molecules, it's done with the rodents. And from in this study design, the males and females both are like treated, and it is treated till the period of primate and like premating 2 weeks and then mating for 2 weeks, and then for the male it's up until the it is sacrificed, and for females it's up to day 4, generally GD 13, 14. Put on GD 14 or 15, the females are sacrificed. And the objective of this study is to check for the fertility and mating part, and if there's some challenge in the conception and implantation, or early embryonic part. And mating behavior, ester cycle, like we have we checked, like ester cycle, if there is some challenges because of the toxicity. Some challenges are happening because of they are toxic and it is ester is there. And the main principle is to check for the gametogenesis and hormonal regulation if they are impacted or implantation physiology challenge. So all those endpoints are checked in. For segment two, it's basically to detect the teratogenicity, and it is to be conducted in two species, rodent and non-rodent. Like we have realized that the thalidomide situation had happened because it wasn't tested in the non-rodent rabbit, so it led to the exposure of females who were pregnant, and media was possible. And here the external visceral and skeletal observations are done, and staining is done. Single staining or double staining can be done to check the skeletal system, and visceral part is also checked there. And the basic purpose of this study is to check if there is some challenges happening at the organogenesis stage, and if there are any challenges in the cell proliferation, differentiation, or morphogenesis is disrupted. In the segment three, it's a larger study, very big study, and pre and postnatal development will be checked there. It's usually done in the rodent and late gestation through lactation until beginning of F1 of spring. The dosing is done, and it evaluates late fetal development and parturition, lactation, all are checked. And because in segment one and two, the females are not allowed to deliver; they are sacrificed before just before delivery or on GD 14 or 15. And in segment two, three, they are allowed to deliver the pups. So the parturition, if there is any challenges in the parturition part, or if the pups are delivered and there is some compromise of the lactation stage. So all those parts which are happening postnatally, they can be checked in the segment three part. And key endpoint here is like gestation length and dystocia, as I said, like for the parturition part, if the parturition is not happening properly. So dystocia is the blockage of like the parturition is challenged. So that can also be checked in this type of study, that is segment three. And it reflects the hormonal, neurological, or physiological any challenges that is hampered because of any toxicant. Actually, it's basically for the um, ICH SFR3 for human drugs. So it's basically designed for the human drugs. And we will be seeing later on, like for chemicals, different study design is there because it may be happen. It might be situation like the law, the like humans are exposed to a very long time. So there it's possibility like many stages can be impacted, like we have seen in the reproductive cycle. So that is checked as the check chemical. So for this was the segment one, two, and three. It was the study doesn't include the male fertility part. Male fertility means like for the segment one, both male and females are exposed. But if there is any compound which is having only impact on the male fertility, so a dedicated male fertility studies are designed where only the males are exposed, and the spermatogenesis cycle actually happens more than 53 or 56 days, and for that reason, the males here in this study are dosed for roughly around 70 days. It may be up to and more than 70 days also, but it ensures like the one full complete cycle of somatogenesis is completed. So, like a regular study, the daily clinical signs, feed weight, and all those activities are observed here, and the body weight is checked for male and female both. And the necropsy for the male happens post the females are sacrificed on GD 14 or 15. So what happens here, like the males are treated for 70 days, and during cohabitation means like males and females are put together to mate, and it's not necessarily like within 4 or 5 days during first cycle the mating happens. It may take up to 2 weeks. So 3, 4 cycles are given to the females, and it is ensured like the mating happens, and proven fertile females are used here. So just to ensure like it's not the female which is leading to the outcome of like any infertility challenges. It's the male only. So proven fertile females are used here, and after the completion of completion of baby and females are sacrificed on GD 15, 14 or 15. So here, there are multiple endpoints that are checked. Like for the fertility index is checked, the mating ratio is checked, and there are like many challenges might be happening because of the psychological or the HPG axis, and there might be challenges with the libido. Like male is not very much interested in mating, and he's losing his like, physiological interest. So all those parts which are relevant for the male is covered in the system. And females is like checked for the like fertility index and gravity rate, and all those parts are checked. But it's just to ensure like whatever is happening, it was because of the male, because only the male was doing so. So this is basic design of the segment one, like males are treated and the females cohabited and continuously like, important of the females are satisfied. And here the maturation of gametes and mating behavior, fertility and pre and post implantation losses that are happening in the segment. This is for segment one study. So all those parameters are checked, and these are the main endpoints for the segment one study. Segment two, it's basically for the developmental toxicity part. So I won't be going in that depth, but just to give an idea, like for the rats, it's roughly around 16 or 17 days of gestation where the exposure is happening, and here only the females will be treated, not the males, because the gestation part, this study is for the to ensure like if there will be any challenge because of the exposure to the female who are of capacity of having any child, like they are still fertile, and or they are pregnant. So only females will be doing here, and the organogenesis period is covered here for where the toxicant will be exposed. And this is the segment three part here, like male and female uh, are mated, and females are those from roughly around the initial of implantation, like we have seen in the first slide, where we were comparing like what all periods are covered. So from GD6, like from the initial of implantation, the start of organogenesis, and up to PP22, the females are dosed, and it covers basically the whole development of the part. And here you can see in the lower side the F1, the pups that were delivered by their parents who were exposed, they are also like mated again. So if this study like basically covers the exposure to the female fetuses also. So for the F1, when they were in utero to their parents in F0, and if some chemical is having any impact on the like oogenesis part. So there might be situation that toxicant led to some challenges at the in utero stage, and at the time of mating, that F1 is not able to conceive, or its further generation, F2 generation, is having some challenges. So these studies cover the reproductive potential of the F1 generation. So the basic design is to ensure like it is not forwarded to the next generation who like haven't come into the world. Sorry, my voice is echoing. Yes, please check if you are muted or not. And this is for the chemical, like extended one generation toxicity studies. Like we have earlier seen most of the studies for was for the drugs, so they were for intended use. And here, like for chemicals which are we don't know its exposure well, so a long period might be there for exposure. So these types of studies like OECD 4, OECD3 is there for extended one generation. Here, like the dosing is done and here the main purpose is to check for the reproductive uh, like challenges. Is there any reproductive like F1 was exposed to chemicals, and is there any reproductive challenges in that? So that is covered here, and many times DABT questions have been asked for from this table itself, like just to ensure like there are multiple cohorts like 1A, 1B, 2A, 2B, 3. So first depends, it depends upon like F1, F0 are mated, and then F1 is there, and the F1 are assigned into like the pups are assigned into these cohorts, and they are checked for their reproductive um, um, evaluation, and like for first A and first B are for the reproductive challenge because it is very much crucial. So a large number of animals like 20 male and 20 females are taken, and second, then after it, the neurotoxicity checked for uh, from these stuff, and then from neurotoxicity and pair animals are there in this. So this table actually is important if you have to calculate the difference. Yeah, if it's available in the OECD 443 guidance, so should be going to. And if you have like, because of time, I am not able to cover all the studies in details, but I will be sharing the contact details if you want to discuss anything, if you want to have like understand anything very well, I will be very much happy to share the details. So from the perspective exposure, exposure of the toxicant, which may be like they might be disrupting the endocrine system. So two studies are there. Hirschberger assay is there for OECD 441 and the neutrotropic assay is there. So in Hirschberger assay, the purpose of the study is to check for any androgenic or anti-androgenic activity of any compound which may be impacting the endocrine system and if there is some exposure like because of the toxicant is there something that is impacting the endocrine system. So here the test system are the immature male rats and they are castrated just to ensure that testosterone, the endogenous testosterone is not there and a study is conducted with or without external testosterone profile experiment is there and endpoints are measured here. So ultimately, what is happening here in the study is basically uh, the, the the animals are exposed to the toxicant. Their background, like the endogenous testosterone, are like they are hold on like there is no testosterone which are produced endogenously, and we are giving an known concentration of like the testosterone externally, and we check if the toxicant is having any positive or negative impact or not. So there might be positive, like it may enhance, or there might be um, negative impact. So ultimately, it will be having an impact on the organ weight. So the endpoints of this study is are the weighing of the ventral prostate, seminal vesicle, and LABC muscle, proper glands and glass penny. So these are all of the rat systems. So they are measured, and if there is any changes, like it may be increasing or it may be decreasing, and then it may be concluded like the toxicant is having any endocrine disrupting potential or not. So this was for the males, and eutropic is for the females. And here, like immature rats are taken, and they are their ovaries are removed, and typically they are exposed for the two consecutive days. And ultimately, similar to the males, here also the reproductive organs are weak, and they give an idea like the toxicant was having any potential of interacting with the endocrine system and influencing it. endocrine chemical like and EDCs are very much of concern these days because a lot of chemicals are there in the environment and they have been known to interact with the reproductive potential and ultimately like in the start of the infection I had informed like more than 15% of people are having fertility related issues. So these endocrine and PFAS and similar molecules are very much abundantly available in our nearest environment and they interact with us and they challenges our reproduction. So these Asperger and eutotrophic assays are one of the best best studies to check for their potential of having any impact on our reproductive system. So what are the like endpoints of the reproductive toxicity studies? The endpoints may be because of the mother side or the paternal side or because of both. So if there is some challenges because of the mating behavior or like the libido is less, like it may be happening because of the male side also or female side also. So all those points are like covered in this types of studies and like pregnancy rate to pre-implantation, post-implantation loss, and all those parameters are checked just to ensure is there any challenges in like from the start of any male fertility or if there is some challenge in the HPG axis or SPA axis or there is any challenge because of the toxicant at the stage of fertilization or implantation or from the perspective of developmental toxicity, it might be a scenario where the fetus is not developing properly. And even after, from parturition point of view, that will be called as a that will be causing challenges to the female. So lactation may also be impacted, and even the fetus that are born, they might be having reproductive system challenges when they will be mating, like for the F1 generation. So all those endpoints are checked there. And from the perspective of maternal toxicity, maternal if the subsequent is having any challenges which are physiological in nature, so clinical evaluation will be helping that part for mating index, indices we will be seeing in the coming slides where it will be ultimately providing the ratio of the females which are having the tendency of mating and what are the fertility challenges and fertility index indices calculated from the study. And even the gestation length may be impacted. And from the perspective of body weight and body weight changes, food or water consumption that are generally the same from like the rest of the study. But here the frequency is different because for like rats and rabbits we don't want to lose any data. So for general toxic study we do body weight of animals at weekly interval, but here it's roughly around on the third or second or third day, just to ensure like we don't miss any data. And it's ultimately like for the females which are pregnant, and if we see any changes in the body weight during the gestation, it gives an idea like were the fetus is infected because of like mm, or not. Just one second. So like if we are having any female which was roughly around 300 grams on GD12 and suddenly it goes to 280. So there will we will get some idea like if there was some challenges during the gestation part, even before the necropsy happens, even before the study concludes. So having a good watch on food weight consumption, body weight, and body weight changes, it gives a good idea comparing like when it's been compared with the control which are proceeding in a natural way. So it gives an indication in between the studies. So organ weights are also checked at the necropsy period, and they also give the direction like what is happening during the topic. And then in Hertzberg and Butyl topic, we have seen like those studies itself are based on the organ weights and they conclude they are concluded on the basis like the chemicals that are impacting the hormonal system. They do lead to changes in the organ, and both are absolute and relative. So and there are multiple endpoints from the maternal side also. So like TCT, WHO, and TSH is also calculated from the pregnant females because ultimately the thyroid, if there is challenges in the thyroid hormone regulation, they also lead to indication that they have some developmental related challenges. And fetal endpoints are also there, which are based on the count of clear corpora lutea and implantation site and so pre and post implantation losses. We will be discussing some part. Mostly these are for the developmental toxicity. So I won't be going that deep into the developmental part. And additional parameters like endpoints are also there. Like for morphology, we check for the morphology part of the sperm, like I had said in the initial part. So there might be like double head or double thing. So morphometric is also there just to ensure the ratio of the sperm in the regular way, and in vitro circulating cells and Leydig cells functions are also assessed in special stage. These are for the special stages. Special cases where like we doubt like from the regular tox studies won't be regular tox studies endpoints. It won't be easier to check which stage is actually been challenged. So like from sperm and egg binding, if there is some challenge in the capacitation of the sperm, and if there is some challenge in the fertilization, so there are additional parameters that can be included in study. And follow-up study like are also conducted for checking the sexual behavior, and population may also be checked for if there is any toxic and which is challenging the population procedure. So that can also be checked, and in vitro uterine strip studies are there to study contractility of the muscles of the uterine, and uterine smooth muscle cells cultures are there. All these studies are for the in vitro. So endocrine system, endocrine assays are also there, which can be checked in vitro studies are done. And measurement of the maternal milk production, the volume, the quality is also done studies where like there's a indication like there is some challenge with the prolactin hormone which is responsible for milk production, and the milk volume is not that much efficient, and the quality is not that much sufficient enough to um, mm, that will help the uh, pups to grow properly. And there are in vitro embryo fetal culture studies also in which the test item is checked if it is acting in the in vitro situation or not, and or it is directly acting on the fetuses or not. So for reproductive development from perspective of endpoints and the genetic distance, as I had said, said earlier, like for males, it's more as compared to females, and that can also be checked because ultimately if the F1 generation which have been like um, produced by the F0 which were exposed to toxicant, and if there is some changes in the anogenital distance, then it indicates that there have been something challenges in their reproductive system. So that can be also checked through these studies. And HPG, like emergence of nipple births and nipple retention is checked in studies where the postnatal observation is done. So that also indicates that if there is some accessory sex organs are infected, and that indicates that there have been uh, potential of the toxicant to challenge the system in adverse way. And for the sexual maturity for rats, for males, it's the PPCL separation. If the PPCL separation happens, it happens when like the sperms are like the first cycle of sperms are ready. So the premature separation confirms the puberty, and if that is challenged, so it also indicates that the toxicant is having potential of toxicity. And for female rats, it's the vaginal opening, and with the first tester cycle starts post that. So vaginal opening it's happening. So it is like the toxicant, and it's been ensured that the toxicant is having an impact on the system. So these are the indices like which are calculated based on the findings endpoints of the study. So male mating index, like it's the ratio of male which were kept with the female and they mated. So it measures the ability of the male to mate. Similarly for the females, and for female male fertility, it's the male which actually led to the making the female pregnant. So it's checked for the fertility part, and similarly for the female fertility part. There's been like in my career also, like in initial days we got to be confused between fertility and fecundity. Fertility actually it's the ability to make a female pregnant, and fecundity is actually the fertility is the qualitative part, and the fecundity is the quantitative part. Like uh, there might be situation like the females are pregnant, but ultimately they are not leading to healthy proper the final outcome. So the fecundity is basically checking for the uh, uh, like the fertility is obviously there, but the male is capable enough to have a good number of kids, like pups and kids in him. So that fecundity is part is also checked apart from the fertility part. Gestation index is checked here if the female with live pups and the number of pregnant females. And the coital interval is the period where the males are kept with the females, and it's the time that they take for mating. So if it's a longer period, that indicates like there were some challenges that the males didn't interacted with the females and they didn't mate it. So a larger teetotal interval is considered to be indicator of LPDP of the function. And mean gestational length, if the gestation is also increased, duration is changed, and the positive evidence of mating is also like calculated there. So if that is also challenged, it may be because of many reasons, but hormonal reason may be there, but ultimately it's a reproductive toxicant outcome. Litter size, number of pups that were delivered, if it as compared to control, if it's less or more, so more generally we are checking for the toxicity part, so it's generally less it's a less number of pups are there. So it is compared with the control, and then we decide whether the toxicant had the ability to decrease the litter size or not. So we've seen like earlier, like for male, at the PPC separation is the landmark for its puberty, and for females is the vagina. So for the vaccine, also there's the requirement of doing the reproductive toxicity studies for the, because if the vaccine is intended for the women of childbearing potential, or it have a chances of exposure to those, so this type of like reproductive studies uh, done there. And it is not required if it's been confirmed that if inactivated vaccine is there and peptide is there, and vaccine is not intended for the population, then only a report of won't be required. And the key study design includes preferably rats, but obviously if it's not of uh, specific to human translatability, so another in like, monkeys or other animals can be considered for that. And timing is usually for making to implantation. And here for any toxic study we ensure like the crucial part is covered. So like a vaccine if is to be given on bi-weekly basis, so we need to calculate that the number of animals are taken in proper ratio, considering the WHO guidance or the ICH guidance. And there, this is also the scenario like if a vaccine is having tendency to generate antibodies, so the study design should be prepared in such a way like the time the organogenesis is happening, by that time the antibodies are there. So it won't be a similar case to like regular one, because on the regular compounds like chemicals or drugs, if organogenesis is starting on GD6, so we will be dosing on GD6. But for vaccine, it will be prior to that, because on GD6, the antibodies and all the reaction because of the vaccine should be present on that day of start of organogenesis. So the designing is done in that way, so that the proper exposure is there. So for vaccine study designing is done somewhat differently to the main like general chemicals and drugs. And endpoints are like similar to the studies that we have discussed earlier, like fertility in the segment 1, 2, and 3. So like many times in between our discussion, I have indicated like NFTs, like non-human primates are used, not the rodents are used, because they offer closer anatomical and reproductive similarity to humans as compared to the rat. And obviously, they are not always used, and it needs to be relevant that it needs to be proven that rodents do not replicate the same pharmacological response as the monkeys are doing. So only in that case, NFTs are required. And obviously, because of the ethical concerns, monkeys are not that much very much entertained until and unless it's been proven that only like monkey study will be proving the that the compound or the drug is safe. And study design are similar to most of the studies that we have uh, discussed, and female and male fertility will improve the menstrual cycle. So here it won't be like the stress cycle that we have discussed. It will be menstrual cycle because it is much more closer to human. And like I had said, that FDA and other agencies discourage the routine use of the NSP um, because of the ethical concerns and multiple other reasons. And for biopharmaceutical antibodies, where the cross reactivity might be a scenario of pharmacology, maybe a thing. So there also NSP may be the only relevant species and they are used. So from outcomes from the study, such types of studies, like we discussed multiple segment one, two, and three of the one generation. There are multiple studies that leads to some data. So for the developmental and reproductive toxicity studies, they generally don't follow the normal distribution, and generally they are require non-parametric methods like Kruskal-Wallis testing, then followed by man-with test. So for maternal parameters to be evaluated ANOVA, and then a test is done, and for litter size, then t-test is done, for fetus, man-with test is done, for sex ratio, number of size test is done. So ultimately here, since it's not like the regular general toxicity studies, there are many metadata that are generated from the data. So some statistically state should be done. And typical general toxic studies, this would be less than 0.05 and biological relevance is quite solid. And study must be powered to detect meaningfully. Randomization and randomization is obviously required for all this. And here in this type of study, litter is experimental unit. Litter means all the pups are from the same dam, and it's not the individual pup that is considered as a unit for statistical part, and it's the litter which is the two unit of observation, and because it avoids this replication, and multiple pups from the same dam is not actually independent. So litter is considered as an experimental unit, and all the stat is done on the in consideration. And there are common pitfalls that happen in study reporting, like treating subtypes independence in fact for the initial stages, studies. We are very much well aware of all the studies, we have done multiple studies, so we are very much well aware. But for the initial stages, if the studies like reproductive toxicity studies are happening at our facility for the first time, it's been a tendency like independent pups are calculated. And there are pitfalls of ignoring the litter effect also, because there might be impact on whole litter. So um, if we are ignoring a single litter, so we are ignoring data, important data. And obviously, like for all types of toxicity studies, statistics are not the final judgment, and it's a tool, and it helps us like with considering both the biological relevance and toxic statistical outcomes. So the final interpretation is based on the understanding and biological relevance, and obviously the statistical support, and then we can conclude anything about the. So what is the future of the reproductive toxicity studies? This one. I had said earlier, not just for the reproductive toxicity study, world is moving towards the NAM, where it is supported that the less number of animals are used. So 3D generated models are there even for the reproductive toxicity studies. It doesn't completely replaces the animal, but there are development in this direction where the organoid chips are there, organoids are there, and they indicate any potential of the toxicant to cause reproductive toxicity. And obviously, those are confirmed by the main studies. But we are moving in a direction where the less number of animals will require, less number of studies will be required. So there is improvement in the direction of AI and prediction models also. I hope like you might be aware, there's a development from Alphabet company, which is parent company of Google. They have developed an molecule for the oncology usage, and and they are proceeding, and they will be starting phase 1 study, and the whole development. Obviously, the animals were utilized, but very less animals were utilized, and Alphabet in collaboration with Novartis and Eli Lilly, they have developed the the that oncology product, and they're moving towards. So I mean to say, this AI is like becoming reality, and even for the part of reproductive toxicity, and soon there will be scenario where like the designing of the drug and designing of the lead candidate will be done by AI. The studies will be based on PBPK modeling and organ chips and organoids and 3D bioprinted materials will be there, which will be helping, and only confirmatory study will be required to be conducted in the animals, and then we will be very good enough to move for the release of the molecule. So, from the perspective of AI in productive modeling, why use AI in the sort of traditional reproductive toxicity? It consumes a lot of time. They are costly in nature, and a lot of animal required there, even for the DRF part, and many trials are there. So AI will replace that part. So machine learning is also there. A landmark study was used, has used to identify chemicals from the FDA database, and it have train different algorithm, and the results the results that are coming out. If you are interested in this, I am having multiple articles with me available. If you wish to have any detailed part of this, so you will be shocked to know like how much advanced the machines are going in that direction. Even from the perspective of slide reading, and there are multiple companies which are using the algorithms to identify if there is some toxicity in particular architecture, or some extra cycling. Even the slides can be read by the machine. So in that direction, the world is moving, and I guess soon in 5 or 10 years, this will be a reality where many of the parts will be done. And Qs are based on the structural similarity. There are many models have been developed where the accuracy will be very high, the sensitivity will be very high, and means accuracy, sensitivity, specificity. These all indicate that the results are very much promising, and they are not in any compromising state. And cross validation also ensure that they are values. And neural network models are there, which deep learning models are there, and which outperforms the traditional machine learning. So machine learning is something which was in the early stages, and now deep learning is there, and they are very much efficient in defining and giving opportunities. And from the perspective of machine learning, there are read across also, and hybrid modeling are also there, which are actually uh, filling the gap between the traditional ways of identifying any possibility of reproductive toxicant and the reality. So this is the role of the reproductive toxicologist. Uh, we are the people who are testing, and through in vitro, in vivo, or in silico, and we are producing the data which is in the open domain, and and which helps the world to identify which all chemicals might be having a toxic impact, not just the reprotox but all the toxicants. So we play a very crucial role in our society where we help the society know which all toxicants are there and what all causes might be there. So we definitely won't be able to completely replace the chemicals. The chemicals will be there, but we can define and reduce the exposure. So we play an important role in the society. So I guess we will be having a break here.